Hello, everyone. Welcome to the fifth webinar of AMS Weatherband's 2024 Gymposium. Really excited you're all here today. We've got the webinar Citizen Science, Advancing Weather and Climate Science, One Observation at a Time, with Ted Rogers, Jason Cooper, Jennifer Dunn, and moderated by Noah Newman. Thank you all for joining us today. Before we begin, I want to address some of the guidelines for the webinar. Please feel free to submit questions to our panel today. You can do that in the Q&A button on the bottom of your screen. We're going to have some specific time for questions, so don't worry if your question isn't answered right away. We see it and we will get right to it when we can. But yeah, please feel free to submit questions throughout the presentation. I do want to introduce our panelists today. I'll start with Ted. So Ted Rogers has been employed by the NWS for over 32 years as a meteorologist, a hydrologist, and hydrometeorologist. His current position is Senior HAS Hydrometeorological Analysis and Support Forecaster at the Mid-Atlantic River Forecast Center, MARFC, at State College. Ted is responsible for managing over 2,000 precipitation gauges used for daily operations, which includes automated hourly gauges as well as cooperative observers and CoCoRaHS reports. So Ted is also a CoCoRaHS observer himself. Also joining us is Jason Cooper, who's the archivist at NOAA's National Centers for Environmental Information, NCEI, specializing in the acquisition, preservation, and management of data at NCEI. And Jason's been there for over 20 years. Also joining us is Jennifer Dunn, was the warning coordination meteorologist at the National Weather Service office in Fort Worth. Her career at the NWS spans over 20 years as well. And in her position as a warning coordination meteorologist, she's responsible for overseeing and maintaining the office's partner relationship program and the outreach and education programs as well. And moderating our talk today is Noah Newman, who's the research coordinator for the Colorado Climate Center and the education and outreach coordinator for the Community Collaborative Rain, Hail, and Snow Network, CoCoRaHS, at Colorado State University. Noah began his career teaching informal science education in 2002 and has led professional development training sessions, classroom presentations, and has been interviewed multiple times on TV, including at the Weather Channel. So thank you all for joining us today. And thank you, Noah, for moderating our talks.
Thank you so much for having me. Let me share my slide here, and I think you're seeing the right one. Yes, thanks so much to AMS Weatherband and the Gymposium. This is a really exciting session, and I'm really honored to be moderating. So today we are talking about citizen science and advancing weather and climate science, one observation at a time. And we're going to talk about how volunteer weather observations make a difference and how to become more effective of an observer. And so the way I want to frame this is kind of into three overall tiers of the way that one can volunteer and submit data to the Weather Service. And it kind of gets grouped into these bullets that you're seeing on here, the overall ease and level of participation that's required. It might have to do with the type of observation that we're talking about. Precipitation, for instance, gets a little trickier, and the cost of equipment as well. And then, of course, just the overall level of commitment. And so with that, I want to, we'll have all three of our speakers go one after another, but I'll mention just kind of each one and what they're going to go over. So first, Jennifer Dunn, she's going to talk about the basic level of participation, where folks can sign up for in-person virtual Skywarn classes and learn how to report sightings and impacts related to tornadoes, flooding, hail, winds, and you can submit data through your phone, through social media, and even apps like what's called one called MPing. Then next, Ted Rogers is going to talk about how precipitation is a little trickier, especially when it comes to snowfall, and how joining CoCoRaHS is a little bit more involved, but their data are not only used for day-to-day operations at all weather forecast offices, but specifically also at river forecast centers and even the snowfall analysis groups as well. And then those data too are also archived into what is NCEI, or which then are basically a global historic data set of precipitation and temperature. And with that, that kind of leads us into what is the co-op program, much more involved. And Jason's going to talk about that, where these are long-standing data sets and from manual observers, and how this is more of an invite-only type of program. But they tend to be, and it really is a bit more of a commitment too. That said, this invite only, oftentimes they end up dipping into CoCoRaHS volunteers and seeing the next and nearest CoCoRaHS volunteer might be a good candidate for a co-op observer. So with that, we will start with Jennifer. I will stop sharing my slides and we'll let Jennifer take over from here. So thanks so much, Jennifer. Oh, and also at the end, we'll go over question and answers for all three of our panelists.
Sounds good. Well, let me make sure. Got the right one here. There we go. All right, just hopefully stop me if you can't see the right screen. I think I've selected the right one, but thank you so much for the opportunity to talk with y'all today. As you can see from my screen here, I'm kind of pulling from one of my youngest child's favorite books, You Can Be Anything, and kind of like Noah led into is you can be a storm spotter and you can help the National Weather Service and you can help our mission of protecting life and property. And it doesn't require too much from you too. So I'm going to talk a little bit about the National Weather Service's Skywarn or Storm Spotter program. There's going to be a little bit of differences between the different offices across the country, which, you know, we have 122 of them at least. So if you're interested in being involved in this on your local or kind of smaller regional level too, you want to make sure to get in touch with your local weather service office and find out what their requirements are, when their classes are, and what kind of follow-up they have. So starting from just kind of what the program actually is, you know, we're here talking about citizen scientists, and a Skywarn Storm Spotter is a volunteer program of trained weather reporters. Now, I have on the screen there that it is primarily a lot of times, but we're also getting close to severe weather season. So a lot of times Skywarn, especially in the Southern Plains and the Central Plains, is geared toward severe weather reporting. But there are different types of Skywarn programs across the country where they're going to focus on the main threats in their area. I've heard of Skywarn presentations that are done regarding winter weather and winter weather reporting, or flooding and flood reporting. So there is a variety out there, but the initial program was developed kind of around the severe weather program and being able to report those near-time, short-term hazards that are impacting life and property. Skywarn Storm Spotters help keep our communities safe by providing timely and accurate severe weather reports, but I do want to emphasize that that has to be done safely. We want you to take your safety as the #1 priority and then be able to make reports to the National Weather Service when you can. If we're able to safely do that in real time, though, those real-time reports are invaluable to our operations. And as you can see, we have over 400,000 trained spotters, whether they are part of a group, which we'll talk about next, or here in a little bit, or they are just simply trained and they report whenever they can. So becoming a locally trained or certified storm spotter by the National Weather Service's definition usually requires the simplicity of attending a local Skywarn class. There might be some other requirements or other guidelines that are provided with that. Might include some type of registration. If you're going to be involved in a group operations, they may have some different requirements too. But for the large part from the National Weather Service's standpoint, just attending a local Skywarn class is at least the first step and maybe even possibly the only step that you need to officially become a trained Skywarn spotter. Now, as I mentioned, there are many spotters who participate in group operations, usually centered around amateur radio with various ARES and RACES groups, and sometimes around public safety groups. And those are going to be a little bit more inclusive, such as emergency management, fire, and police. Probably not a group that you can join, but if you are employed by them, they may have some type of formal activation that they do there. So these groups often have some form of formal activation where their members send out activation notices and they start their reporting criteria and the reporting procedures through there. But you certainly do not have to be part of a group to be a trained and a helpful storm spotter. No activation or group participation is necessary to be a trained spotter, and you can simply report from wherever you are whenever there's hazardous, threatening, or severe weather that meets the criteria of what needs to be reported. So the Skywarn Storm Spotters and the program itself, we do spend a lot of time and effort on because it's very important, because our spotters become our eyes and ears out in the field when the meteorologists are in the office and are unable to be out there observing the threats themselves. So our Skywarn spotters provide ground truth, which is the missing link between the tools that the meteorologists are using and analyzing and putting together that complete 3D picture. So there are a number of really good tools, really powerful tools that we use, but they don't always tell us the complete story. So with satellite imagery, we can see where clouds are developing, where storms and boundaries are, and some of the properties as thunderstorms develop, but we can't see inside and we can't see below those clouds. We have our radar with the 88D that you see there on the right, allows us to see inside the storm, look at the wind features, monitor growth, intensity, hail cores, rotation. But again, it's not going to tell us exactly what's reaching the ground. And it really will never actually sample a tornado itself. Remember, the radar starts at about 90 to 100 feet typically up above. So is that in contact with the ground? Only a set of eyes safely can hopefully give us that information. And we can use weather models and automated weather stations, which of course our presenters here today are going to build on that with CoCoRaHS and the co-op program also. But automated weather stations are spaced few and far between, and they're really good at measuring things like temperature, dew point, and wind, but they really don't necessarily have a good sense of telling us if it's hailing or what the size hail it is, and or about any type of ongoing tornado or any developing tornado funnel cloud of that. So our Skywarn spotters, again, they're providing that ground truth that is the missing link. But the reports that they provide to us also assist us with warning decisions, meaning, should we continue the warning? Do we need to cancel it? Do we need to upgrade and change it? Sometimes we don't, while we're doing our radar analysis, we may not exactly know, all right, the storm looks like it's producing golf ball hail, but is it actually? And if we don't have any reports, our confidence in the fact that it's producing hail may go down. So having that confirmation helps assist us with actually making decisions about what warnings and what type of warnings we need to issue. And then it also helps tailor our messaging. Social science research tells us that people are more prone to take action when they have the ability to confirm the threat and verify it. So a warning, like a tornado warning that says tornado has been confirmed by trained spotters or by a source, versus a warning that says it's radar confirmed. When we're actually to say it's been visually confirmed, they hopefully take action more often and a little bit faster also. So we can tailor our messaging that way. We can tailor our messaging on social media and through our graphics to tell people to take action and take shelter when they need to, for example, during a severe weather event. We will also turn around and quickly update information as we get real-time reports. It might be that we're now messaging people in path of the storm that the hail size is increasing, and they certainly need to be inside and away from windows. There's a lot of things that we utilize to help tailor that messaging when we do get that real-time updated information. And then your reports too also help drive safety response actions by public safety, emergency management, community responders, whether it's putting out barricades around flooded roads, closing down roadways, maybe in winter weather that they know are problematic, or activating outdoor warning sirens. Sometimes having, again, that radar confirmation versus actual confirmed helps drives some of those safety response actions too. Storm spotters play a critical role too as part of what we call this larger aspect of a safety team, or what we call an integrated warning team. And some of the main players on this team are, of course, your meteorologist in broadcast, but also in the National Weather Service, where we are exchanging weather expertise, analyzing model data, analyzing radar data, issuing watches and warnings, and then the media is helping us amplify that message and get the warning information out to the public. Our other sector there is a lot of times that public safety sector and with emergency management. They are acting, responding, preparing ahead of time and acting and responding to their communities. But the spotters are providing that ground truth again, that kind of links it all together. All that weather expertise analyzing the radar, but knowing what's actually happening out there helps our entire safety team work together for the betterment of the people that are impacted in the path of that storm, or a system that might be coming up in a couple of days as well. So there are many ways that spotters can report to the National Weather Service. And on the screen here, you'll see a couple of examples. But again, reaching out to your local National Weather Service to verify the best ways to report to them is going to be a part of being an efficient storm spotter, but also you'll learn that at a local Skywarn class too. So there's various phone methods and social media. As I mentioned, we do continue to work with amateur radio. Email addresses into our office along with our phone numbers are usually available at the bottom of our web pages. And then again, Skywarn web pages might provide more information. And then as Noah mentioned, there are a couple of apps, and one app that we look at also in some sense is the one called MPing, which is free on Android and iOS devices, but it uses a simple drop-down menu to be able to send reports. So you can't really add any additional information in there. The MPing app, remember too, is not a National Weather Service app. We just kind of get the benefit of looking at that data. It is a research-based app, and it is delayed getting into the National Weather Service. So for more imminent reports, like developing tornadoes, ongoing tornadoes, you'll want to use one of the other methods to more quickly reach your local National Weather Service. But again, check with that office and know the multiple ways that they accept and can take reports. And then even if you don't know which office to report to, we're pretty good about relaying information too. So if you happen to call our office here in the Texas area in North Texas, and that's actually an office covered by our neighbor in Shreveport, we'll make sure that that information gets passed over too. And then you're actually helping a much longer climatological historical database that we keep. So your report doesn't just get written down on a piece of paper and then put off in the recycling bin later. Every month we document all the storm spotter, all the storm reports that we get during the month. We certify it, and it becomes part of our larger monthly storm data or storm event database, which is run by NCEI, National Center for Environmental Intelligence there, or they kind of keep a hold of that. And this database goes back, I believe the starting point, if I remember, it might go back to the 1950s-ish, but somebody's going to be like, why don't you know that, Jennifer? But you'll actually see your reports in there when they do get documented. And then this database is used for millions of reasons, whether it's agriculture, construction projects, research, historical analysis on things. All of this is used by a variety of companies to also better our economy across the country as well. That's what I have for today. Again, if I think we're going to hold questions till the end, I'm going to turn it back over to Noah, but thank you again for the opportunity to speak to y'all today.
Thanks. And yeah, as we transition, the next speaker is going to be Ted Rogers.
I'm looking for the sharing here. Let's see. Okay, and I am going to talk about the importance of CoCoRaHS gauges and how we use them in the Weather Service, and more specifically in my office, the Mid-Atlantic RFC. Again, I'm the senior HAZS forecaster at the Mid-Atlantic RFC, and our main job is to put out accurate river forecasts to help protect lives and property. And the way we do that is we collect precipitation observations for the past 24 hours. We do this each morning. And then from that, we generate river forecasts, and we also use the data for a lot of other things. So we're just going to jump right in. Like I said, at 12Z each day, you folks put your observations in for 12Z, and we take those observations. We use them for a lot of things. We use CoCoRaHS co-op observations. We use a lot of hourly observations from automated gauges as well. We use ECP and MADIS gauges, which are maintained by the USGS and the public. MADIS gauges could be a Davis weather station. We actually use a lot of those and they actually provide some very good data. We still use some iFlows data, which is kind of fading out. It's been around for a while, but what's popping up now are these state nets. There's funding provided to some of the states, and they're producing their own network of precipitation gauges. And that's really helpful for us as well. New York State produced one about probably 6 or 7 years ago. And we use those gauges every day in our operations and for many other things, as you will see. Also, some co-op gauges automated, and not a lot of those are maintained by the Weather Service and the public. For all of these gauges, these hourly automated gauges, there are some limitations. At any time, a gauge could break down and stop reporting. Some, and in fact, a fair amount of these automated gauges are not heated. Therefore, when we get winter weather, frozen precipitation, which in our area extends up into New York State, we can't use those gauges in the winter. So what we rely on heavily in the winter are manual gauges, which are what you folks produce, CocoRaHS and co-op gauges. The best thing about these gauges are there's little to no maintenance needed. We just need you folks to report a good number each day. That could be a limitation. I say a limitation only because the hourly gauges, we get reports every hour. But still, that one report a day is very helpful for us. And we put that back into the last 24 hours. We calculate hourly measurements from that report that you put in. And one thing I also want to mention on this page, I have these 25 to 50 and 50 to 75%. In the summertime, we tend to use all of our gauges. There's really no limitation. So the co-op and CocoRaHS gauges probably comprise about 50% of what we do. And the hourly automated gauges provide the other 50%. What happens in the wintertime when it gets colder, we get snow and frozen precipitation, we have to turn a lot of those automated gauges off. So the percentages change. And when we have a lot of those gauges off, the data that you provide could be giving us up to 75% of our precipitation reports. And believe me, that's huge, because I'm going to show you where we use all that data next. So here's a couple of nice graphics. On the left, this was a precipitation map taken back in June of 2021, but it was a really good map I've used in another presentation, and it illustrates the amount of manual and automated precipitation gauges that we use. You know, on an average day, we're probably using at least 1,000 to 1,300 gauges. And on some days, we're going to be using more like 1,500 to 1,800 gauges when they're all reporting and when they're all turned on. So, you know, what do we use these gauges for? Well, the graphic on the right here is our MPE graphic, multi-sensor precipitation estimates. And what this graphic does is it takes the radar precipitation estimate and it combines with the ground truth of the gauges to produce a product that is much better than just the precipitation that the radar puts out. But the gauges actually help adjust that field. If the radar is running hot, it pulls the amounts down. If the radar is running low, it helps lift the amounts up. But this product's important because this MPE, or the national product, which is called MRMS, basically the same type product, just a different subset of gauges that are used to calculate it. It's our primary forcing for our hydro model. And that's very important because the biggest things for us are the past 24 hours of precipitation and the next 72 hours of precipitation. The precipitation is our biggest forcing in the model, and it's our biggest factor in making good river forecasts. So if we get good past precipitation and we have a good QPF, forecast precipitation, we can usually generate a pretty good river forecast. So good data is really important to us. Another thing we use your precipitation gauges for, and this one really is big, because there was a time when we used to get, instead of ASOS and AWOS observations, there used to be a manual observation taken at the airports. And you get a lot of the same information that you do now, but you used to get a lot of snow information, how much snow fell in an hour, what the snow depth is. And when that stuff went automated, we kind of lost a lot of that data. And, how do you replace that data? Well, what happened to come along and what has been growing at an incredible rate is CocoRoz. And right now we are just importing, we're in the process right now of putting over 700 new CocoRoz gauges into our database. And this covers the Mid-Atlantic region from New York all the way down to Virginia. And we're using those gauges because they provide good data and we need them for a lot of things. This snow map you see on the left was taken just a few days ago. Our primary input for snowfall, 24-hour snowfall and snow depth are CocoRoz. We get more observations from CocoRoz by far than any other form for snowfall and snow depth. So you folks are out there measuring snow, putting that into your CocoRoz observation, measuring the snow depth. We take that data, we display it, we have maps on our webpage that we use it for, and it's very good data and it's usually pretty doggone accurate too. So not only do we use it for precipitation and forecasting rivers, but we use it in our snow water equivalent map to accumulate snow. And why is that important? Well, whenever it warms up and that snow begins to melt and we get rain on top of that, you're adding, rain and the snow melt. So it's really important that we know how much snow is out there to melt. If we get a good number out there and we get a good rain forecast, there's still a lot of other factors involved, but those two things alone will help us produce a better river forecast. And oftentimes when we get to this time of the year, not so right now because there's not a whole lot of snow on the ground, but this is the time of the year where we have a snowpack up in the northern part of our area, starts to warm up, we start to get rain events, and we can have some pretty decent floods this time of the year. So that SWE information that we keep and we use is very important for our forecasts. And for the folks that live along the rivers and have interests along the rivers, it's very important for them too. So those observations are great. Please keep them coming. They really help us. Some other applications that you might not realize or think of how we use your data. Precipitation departure maps are a real big thing. Folks love to see those. Our most common ones are 7-day, 30-day, and year-to-date. But those maps we produce for the entire Mid-Atlantic. We've been doing it for many years. And there's a lot of people out there that rely on that data to figure out how dry it is, how moist it is, and they make decisions based on that. So those maps are really important, and your precipitation observations go right into those. Again, like I mentioned on the previous slide, you are our primary source for 24-hour snowfall obs and snow depth observations. We get more of those from CocoRoz than anywhere else, and they're generally really good too. So it's really important to us, especially as we keep track of that. Some other things you may not think of, I mentioned precipitation is important to us past and future for making good river forecasts. Well, some other things that go into those river forecasts are soil moisture. It's important to get good precipitation observations so that we know how much precip fell in what places, because our model keeps track for soil moisture considerations. What that means is if you get a ½ an inch of rainfall, if you have really moist soil, a lot of that rain will make it into the streams, creeks, and rivers. But if the soil is much drier, a lot of it will get trapped in the ground before it gets to the streams and creeks. So those calculations are important as well, but the daily precipitation observations that you folks provide help us to produce those calculations. Another big one is the flash flood and headwater guidance. You may ask, what is that? Flash flood headwater guidance is basically guidance that tells you how much rain it will take to produce a flood at a certain location. We have a lot of headwater points which tend to flood pretty quickly. When you get rain, it only takes a matter of hours for the gauges to go up and flood. So it's really important to know how much rain it will take in 1, 3, 6, and 12-hour time frames to produce minor, moderate, or even major flooding. That's very good information for the WFOs because they're the guys that put out the flood watches. When you see those come out, they come from the WFOs, but some of the information they might use is flash flood headwater guidance, and we produce that, and that comes from your precipitation observations. Some other uses, the Maryland Department of Environmental Protection uses past precipitation for shellfish harvesting decisions. For instance, if we get real heavy rainfall around the Chesapeake Bay and it produces a lot of fresh water into the bay, that produces a lot of bacteria, and they may actually close the shellfish harvesting season for a time until the bacteria levels and salinity get back to where they should be. So again, heavy precipitation will maybe trigger some decisions for folks in the bay, and we get that information from your observations as well as other areas. Another one use is the Delaware River Master. This is the person that makes the decision on releases from the New York City reservoirs. And why are those reservoirs so important? Because those reservoirs hold drinking water for 9 million New York residents. So it's really important that they don't want to release too much water, especially in the winter and spring, because in case we get dry in the summer, but they use our past precipitation to help them make decisions on how much water to release. So a lot of good things going on with your observations. Not only did we use them just every day to produce river forecasts, but we use them for a lot of other things. And just a quick recap. Again, in the winter season, with a lot of our unheated gauges being turned off, your observations can account for up to 75% of all of our gauge observations that we collect. Very important to us. Direct input to the MP MRMS, which is our primary forcing in the hydro model, and it gives us our biggest bang for the buck for the river forecasts. Another less important one, but still an important one, the radars. I mentioned how the radars produce the fields, the precipitation fields, and the gauges help to adjust it. When those gauges get pulled in, they do help to adjust the fields, and they do adjust the radar biases as well. So a lot of real good uses. Improved observation input improves our river forecast. We use it to calculate soil moisture. We use it for flash flood headwater guidance, our primary source for snowfall and snow depth. And again, that's important for us when we're looking at high water and floods. And a real good thing about the CoCoRaHS observations is they're generally accurate and reliable. Even with freezing and frozen precipitation, there are many gauges where we just don't have that. So we really rely heavily on that. And as I mentioned, I'm in the process right now of adding over 700 new CoCoRaHS gauges. If you happen to live anywhere from southern New York to central southern Virginia, your gauge might be pulled in to our database in the next couple of weeks. So again, thank you for all the hard work you folks do every day and your observations. They're really important to us, and we use them in many, many ways. Thank you very much.
Thank you so much, Ted. That was awesome. And I actually personally had forgotten about the shellfish operations decision-making that can occur off of precipitation data. That was fun to relive that as well. We're going to transition to Jason Cooper now, who is going to talk from the perspective of NCEI about the co-op program. So Jason, please take it away.
Excellent. Thank you, Noah. Thank you, everybody, for joining this session this afternoon. I really appreciate the invite, and greetings from NCEI in Asheville, North Carolina. I have the pleasure of presenting this morning from the NCEI archives in the basement of NCEI's Asheville, North Carolina headquarters. You can see behind me, I'm in the main archives room. There are currently 36,568 boxes of weather, climate, and other environmental data in the archives in this main room. And we've got two other rooms as well that are smaller, but also contain the history of environmental observing throughout the United States and also around the world. And with that, I'll go ahead and start sharing my screen so you can, so we can work through the presentation and get to those questions and answers that you have. Excellent. So again, thanks for the opportunity to present to you all this afternoon. I'm going to talk a little bit more about the U.S. Cooperative Observers Network, and also from an archivist perspective, a historian. Our presenters so far, Jen and Ted, talked about how your data are collected and used on, from an instantaneous, from the moment you see a tornado or hail or a wind gust, you can report it to the National Weather Service, and they will use that information instantly to verify what they're seeing via their instrumentation. And Ted will take your information and use it to develop monthly and seasonal forecasts and inform decision makers on that time scale. And then all of that data eventually arrives here at NCEI, where we use it to inform decadal and even further back into the past to inform some decision making going into the future on a climate scale. So to recap what NCEI is, we are NOAA's data archive. We have over 30 petabytes of environmental data. Much of that is satellite and radar, some of your high volume data sets, but we also have the co-op network. You can see some of the platforms from which we archive data as well. You can see NOAA ships, NOAA satellites, and that is a weather balloon being launched from an NWS forecast office. The data in the archive are from thousands of years ago. Yes, we do have a paleoclimatology branch looking at ice cores and tree rings and soil samples to just yesterday. Data are coming into our data center, electronic data center on the 3rd floor from yesterday's observations. And our mission is preservation, stewardship, and access to that data from the beginning of the collection, all the way up until yesterday. To focus a little bit more on volunteer weather observations, which is why we're all here today, we'll go back to the beginning. Weather observations originally were conducted by hobbyists and journalers and founding fathers. Some folks do not know that 2 of our early presidents, George Washington and Thomas Jefferson, were avid weather observers, and we have those observations here in the archives as well. A couple of examples that I've included here on the right is excerpts from the diary of the Reverend Samuel Checkley from 1735. So what was done here is that the Blue Hill Observatory went out and looked for diaries from American citizens, and even this one pre-American citizens, being from before the dawn of the United States back in the 1730s, and culled through those diaries looking for weather information. So you get rather coarse information. You can see when it was cold, when it was cloudy, maybe when it was windy. One of those lines does say snow at night about 3 inches deep. So there was a 3-inch snowstorm in Boston on, what is that, February 12, 1735. That is weather information collected by a volunteer, even though he didn't know he was helping with climate research. He was taking those observations and recording them in his journal. To the lower left, you can see an early observation from a volunteer observer who actually had instrumentation, which is rather rare for the date of this observation, which is January 1832. He was recording temperature, barometric pressure, rainfall, and wind direction 4 times per day. Again, 1832, New Bedford, Massachusetts, on the southeastern coast of the state of Massachusetts. So very early volunteer weather observations here in the NOAA archive. The first volunteer weather observer network was created by the Smithsonian Institution in 1849. The first cadre of observers was numbered about 150, but by 1860 there were 500. Unfortunately, that ended up being the peak number for the Smithsonian Institution volunteer network because the Civil War started the very next year, and we have very, very few weather observations from the Civil War era, especially, and as you'd imagine, from the South, on the order of just a handful that made it through the Civil War, mostly at military outposts. This observer network was transitioned to the United States Army in the mid-1870s, and the image you can see here is the first ever weather observation from the city I'm in right now, Asheville, North Carolina, from July of 1857. So again, pre-Civil War in the South. You can see barometer and thermometer observations there informing the climate of this area all the way back over 150 years. In 1891, the U.S. Weather Bureau was founded, and the Volunteer Observer Network was transitioned over to the Weather Bureau. So this is the birth of the National Weather Service Cooperative Observers Network in earnest. So what you can see on your screen here is the observations from August of 1895. So this is a very early cooperative observer form from the state of Idaho. And you can see the Weather Bureau stamp there in the lower right corner. Actually, they've stamped the back of it. So what you can see there is, again, it looks like 3 observations a day. This particular station had a maximum and minimum thermometer, reported the prevailing wind direction and the character of the day, which is a simple clear, cloudy, rain, snow, giving a taste of what the day was like at this particular co-op station. From 1891 until about 2000, we had a century plus of stability. And what I mean by that are some of the things that make up a really important weather observing network from a climate perspective. Co-op stations have standard instrumentation, so we know exactly what instruments are being used to collect the observations. They are regularly maintained by the Weather Service, obviously faithfully reported, and this can be noted across generations in many instances. So we've seen many cases of observers who have conducted observations for 30 or 40 years, and they hand off that responsibility to their children or their grandchildren to continue the unbroken observations from their station for decades, for many decades, and in some cases more than a century. And I note there that a number of station histories date back to the pre-Weather Bureau era, so back into the Smithsonian and the U.S. Army Signal Service management of the volunteer network. What I've pulled here is some station history from State College, Pennsylvania. You can see the lat lawn elevation, but what I wanted to note was the period of record. The start date for this particular station, January of 1893. The end date, I pulled this image a couple of days ago, so we had just received data from, what is that, Wednesday or Tuesday, I guess. And most important to note is that the data coverage for that period of record is 99%. So 100 and, oh, my math is bad, over 130 years and 99% coverage is pretty amazing and very useful from a climate research perspective. I mentioned the stability till around 2000. That's when we entered the digital age, when volunteers began to submit data electronically. So all these pieces of paper behind me gradually stopped flowing in, and people began to transition over to a system known as the Weather Coder system. So they could log in and enter their data for a particular day, or just wait till the end of the month and enter the data for the entire month. That was wonderful. In most cases, NOAA got the observations more quickly rather than waiting for the mail to come at the end of the month. That data would arrive on a daily basis. But we had to make some concessions. As I mentioned, we had observers who had been conducting observations for 40 or 50 years who had never used a computer before. And they said, matter-of-factly to NOAA, they said, if you make me enter my data into this newfangled computer thing, I will stop. So we did continue to receive paper from those folks. And our last paper observation came into this archive in 2018 when the last observer who submitted by paper retired from service. The co-op network today, in the history of the program, there have been over 33,000 stations come and go. Currently, there are just over 8,000 stations that reported observations in January. And on the right, you can see a list of, this is an alphabetized list of all of the stations, but this only shows about the first 40 or 50 that start with A from all around the country, and some of the metadata from those stations. This data goes into the Global Historical Climatology Network, or GHCN Daily. That is our foundational climate-ready data set with full quality control and usefulness in weather and climate research applications. And it also is used to inform the climate extremes. The State Climate Extremes Committee is headquartered here at NCEI, and we work with the state climatologists and the WFOs, the NWS Weather Forecast offices, whenever they see or have reported to them what looks like it might be a state record. Those reports are submitted to the committee, and they adjudicate and determine whether it is or is not the state record. On the lower left, you can see, if you hopefully can see, the list of the state records for the state of Maine. And what I wanted to point out here to you is that the numbers on the rightmost column, where it starts with 175, 875, that is a co-op number. And you can see what 4 out of the 6 records for the state of Maine have come from co-op stations. The other 2, 14764 is the Portland Airport for the 24-hour precip record. And then the min temperature came from actually a U.S. Geological Survey station up on the Canadian border. But again, the majority of the state records in that database come from co-op obs. So very important data inputs from a climate perspective. Besides climate research, NCEI has customers from a number of sectors of the U.S. economy. So what you may realize that folks in the agriculture and energy and even the transportation industries are some of our top customers, and they are looking to the co-op data to try to get information about what's been happening in areas in which we don't have paid observer stations. So this makes our network dense enough to be usable by some of these sectors, which includes insurance and legal services, includes aviation, obviously, but also includes health and finance, municipal services. How often, do we need to open up shelters or plan to plow our streets to protect our citizens from harsh weather? And of course, historians are some of our prime customers as well. So the cooperative network remains the gold standard. I mentioned a few of the reasons why a few slides ago, but just to kind of go over why this data is so good and so reliable, it's the stability, the consistency, and the quality. We have standardized, well-maintained instruments at regularly inspected sites. So that's very important as well, because siting can change. If trees grow up around an area or trees are cut down, areas are paved, that changes the exposure of the instrumentation. And we need to know about that in order to correct biases and use the data correctly from a historical context. There are well-documented station histories created and sent in by the National Weather Service, and they train their observers so that they can operate in a consistent manner and provide the data on a consistent basis. Just a quick thank you. Thanks again for joining us this afternoon or this morning, depending on where you are. And thank you to all your cooperative observers out there, whether you're in the CoCoRaHS network, whether you're a Skywarn spotter or in the NWS Cooperative Observers Program. I included it on my last image here, pictures from the National Cooperatives Observer newsletter from the summer of 1990. And you can see some citizens back then who are getting awards from the National Weather Service for our 25 to 50 years of service. Some very, very proud long-term observers, and we're very grateful. Thanks, everybody. Noah, back over to you, I believe, for Q&A.
Yeah, thank you, Jason, so much. That was totally awesome. I gotta say, so of course I work at CoCoRaHS, but I also work for a state climate office, and we've got old archives of our own. In fact, those original written records that they would mail in their carbon copies to your office. And what I love in what's, I kind of joke, but it's also true. You pull out one of those old books and you crack it open, and you can almost smell the cigarette smoke from the room. So it's really neat to see those old handwritten records. So if I can have all of the panelists go ahead and turn your cameras on, and I will ask a couple of questions that are starting to roll in. The first one I'm going to ask for Jennifer, and it's related to those storms, those extreme reports, the storm spotter reports that can be submitted and end up in that archive. I will really quick say that if you're a CoCoRaHS observer, you can submit what's called the significant weather report, and that goes immediately to your local National Weather Service office and literally rings an alarm on their desktop. So, but the question is to Jennifer about those storm reports. How does one look those up and access them? And maybe, I'm sure you might describe it, but maybe after, as I'm asking the next question, you can put it in the chat for the attendees to listen or to find. So,
yeah, absolutely. So all of the reports go into, it can be an easy internet search for Storm Event Database, and I can drop the link in the chat room also, and that's where you can find all the storm reports, at least the ones that we've received, have been certified and passed on. Note too, though, that there is a 2-month lag in that. They give us 2 months to kind of go back and collect. My office is one of the notorious ones for doing it every 2 months lag time there too. So for instance, right now we'd be finishing up December. Well, we would have just finished December. So we'll get started on January for those of us who are kind of falling a little bit behind there using that 2-month deadline.
Cool, thank you. And the next question is going to go to Ted related to River Forecast Center. But before I ask the question, I'd love to just get a little bit of interactiveness going on with the attendees in listening in. You can raise your hand if you are a member of Skywarn or CocoRaHS or even a co-op volunteer. Go ahead and raise your hand. I'd love to see how many people in the audience are already doing it. So this is fantastic. Oh, love it. Yeah. So many of you are raising your hands. That's great to hear. So Ted, the question for River Forecast Center, Nancy asks, so I can look at a forecast of a river for me specifically to know when the best time to go kayaking is. Is the answer yes? Can someone look up their nearest river and see the nearest stage and potential predictions?
Yes, yes, you can get that right off of our website, weather.gov/MARFC, or any other RFC instead of MARFC. And we start on our homepage with a map of our area and all of the forecast points on there. If you pan over one, it will show you the hydrograph for that point. If you click on it, it will take you to the page with that hydrograph, and it will give you a lot of information about that location. It's kind of important to know what good river levels are at a certain location if you want to go, have some recreation, because too much water could be dangerous. Not enough water, may give you what you want to do. So it's helpful to be familiar with the location, but we update those forecasts every day. And when there's more weather and heavy rain going on, we update them more frequently than that.
Thanks so much for that. And yeah, I think even just very simple, water.weather.gov will get you to the landing page where you can look for river forecasts or for river levels. This is a question possibly still for Ted, but maybe for any of you on the panel. What organization can use the result of an automated weather station? So I'm prompting one of you to maybe mention the CWAP program if you want to talk about that briefly. And if none of you want to, or Ted, if you're talking, you might have gotten muted.
No. I know Jennifer, she mentioned she might want to mention something about CWAP. I know it's important because the information from there goes to the Weather Service. If you can get your information on CWAP, your data on there, then we can use it. Citizens Weather Observation Program. I have an automated Davis weather station, and I do CocoRaHS, and my Davis is on CWAP, and we actually use it in our observations in the morning too. So
thanks.
Yeah, Ted covered it pretty much too, but there's multiple ways that we can view that data from CWAP also. And one of the main web pages that I like to use is the National Weather Service's Weather and Hazards Data Viewer. So that's publicly available too, where anybody can go in and look at that data and see the real-time observations. Like Ted too, CocoRaHS and Davis Unit, that's all up there too. Us weather nerds got to do that. But recently I went in and I looked at all the rainfall reports from our area from yesterday. So anybody can go in and view that as long as they are on CWAP or have made their data available through that or through MADIS, however the proper channels are.
Thanks. We're starting to run low on time. We've got a few more minutes and we'll try to squeeze in a couple more questions. This one is for Jason. All those archived records behind you, are anyone digitizing those from the past as well?
Yeah, that's an excellent question. So around the time that the Weather Service was converting from paper-based observations to electronic data submission, we began to receive funding from Congress to be able to digitize what we already had. And digitizing involves scanning, obviously, to convert the paper forms into image-based formats like PDF or JPEG or TIFF. But it also involves keying those observations, right? Getting the data off of the forms and into our data sets so that we can conduct climate research and make that data publicly available. Congressional funding dried up in 2011. So right now we are working on partnerships. So researchers who are interested in whole collections will partner with them, split funding, split labor resources to get that done, and make as much available digitally as we can. And a couple of the projects that we've done lately, we had a researcher looking for the ship weather observations from the U.S. Navy during World War II. From a climate perspective, we're heavily reliant on military and also private ship observations. Well, there were very few ship observations during World War II for obvious reasons. So that military collection had a lot more value than it otherwise would. And then also, we also got a grant to finish up scanning the cooperative observations from 4 states. We had 46 states completely scanned and available publicly. The last 4, Idaho, Montana, Washington, and Oregon, we finished those up, and I'm working on getting those online right now for public access via a tool at NCEI called IPS, the Images and Publications System, and we can share a link to that. So yeah, we still obviously have a lot of work to do. About 5 to 10% of what you see behind me has been scanned and available. And if you'd like something that may not be scanned yet, give us a call.
Yeah, and I'll mention too, those old paper records are still valuable because once they get scanned and even keyed in, there could be a typo or you misread it. And every once in a while, we'll get a question into our office and was it really a high temperature of 79 degrees? And you go back into those records and it turns out that 7 was a 4 and it was just miskeyed. So it's really fascinating. Next, while I've got you, Jason, briefly, how does one become a co-op observer?
They would reach out to their local weather forecast office and they would explain where they are, which is very important because the Weather Service is very invested in getting observations from unique places. So unfortunately, if you want to be a co-op observer and your neighbor 2 doors down is a co-op observer, you're probably not going to be recruited into the network. However, if they've had a recent retirement or somebody has given information that they're going to be leaving the co-op network for whatever reason, whether they're moving, retiring, they're tired of doing it, unfortunately that does happen, then the Weather Forecast Office could reach back out to you. If you have sighting that's very similar to a station that has existed in the past, they may look to fill that gap with you. And they would provide you with instrumentation and training, and you would become a cooperative observer and hopefully extend one of the existing stations and keep that record going on into the future. So it all starts with your local weather forecast office.
Thanks so much. The last question I'll field myself. The question was, is there a process for NOAA and NCEI to accept and use and archive citizen science data? And again, specifically for CoCoRaHS, as you're a volunteer and you accrue a certain amount of observations, the minimum is 100, then your data will be looked at a little closer and then eventually accepted into that NCEI product called the GHCN Daily that Jason talked about. So yes, it takes a little bit of time and consistency to as a CoCoRaHS observer for your data to become part of NCEI's collection, but it is the case, and we've got thousands of CoCoRaHS volunteers whose data are in NCEI's records. So I think with that, we are out of time, but I want to thank again Jennifer, Ted, and Jason, all 3 of you, for talking about Skywarn and CoCoRaHS and co-op. This has really been a fun panel to moderate, and I hope that all of the attendees have enjoyed it as well. So with that, I think we are ending just within a minute or 30 seconds to spare. And if any of our other panelists have anything to end with related to the Jamposium, I think we've got a moment to spare.
fantastic. Thank you very much, Noah, as well, for moderating the event. For those of you joining us, we still have one more event today in the Jamposium. I just put a link to it in the chat for our next webinar on global weather modeling. Thank you all so much for joining today. This was an excellent discussion. And thank you to speakers Jason, Jennifer, and Ted for your contributions today. It was lovely. Thank you very much.